All right, so today's lesson is called Chapter 4.7, Arithmetic Sequence. So the whole point of today's lesson is to identify if a sequence is an arithmetic sequence or a geometric sequence. We've talked about this before, and the difference between the two is that arithmetic, you're adding a certain number in the pattern, and with geometric, you are multiplying the same number in the pattern, okay? So let's go ahead and go over some basics. For example, we have a pattern and we have 5, 10, 15, 20, 25. So here we said that the 5, you were adding 5 to each number. Okay, so the 5 would be called the common difference. The a sub n at the very end of the pattern there, whenever you see that in a problem, that is describing the nth position. Each number is in a position, right? So for example, the 5 is in the first position. The 10 is in the second position. Those are very important whenever it comes to finding out what the equation is for the pattern. So right here, pointing to the 5, you would say this is the first position. Okay, so the directions for the assignment in the first part, would say write the next 3 terms of the arithmetic sequence. Okay, so for number 1, we have -12. So we have -12, 0, 12, and 24. The directions say to write the next 3 terms. So the next 3 terms here, first you have to find out what is the pattern, right? What's happening here? It looks like we're adding how much? So then if you know what the common difference is, let's find out the next number after the 24, the next 3 terms after the 24. So when you add 12 to 24, we end up at 36. After 36, we get to 48. And then the last term, 60. Very good, guys. And there we are for number 1. Okay, number 2. Zero 0.2, 0.6, 1, 1.4. Okay, what are the next 3 terms? Very good, 1.8 is correct. After 1.8, we have 2.2. Very good, guys. And then 2.6. Number 3, We have 4, 3 3/4, 3 1/2, 3 1/4. Okay, the next 3 terms. What's the next number? 3, very good. What's next? 2 3/4, very good. And the last term? 2 1/2, very good, guys. Okay. So I'm so glad you understand how to find the next 3 terms. Okay, so the next part, the directions say, write an equation for the nth term of the arithmetic sequence. Then find a sub 25. Okay, there we go. Okay, so this is the part that I wanted to make sure that you did understand how to do it, okay? So the next example, we will call it number 4. And the pattern says 4, 5, 6, 7. Okay, so that's a very basic, very simple sequence, right? We can tell what the next numbers are going to be. But what we need to do is write an equation. So that's what we're going to learn to do, okay? Then what we have to do is find a sub 25. What does that mean? That means what's going to be the number in the 25th position. So I'm going to show you how to do that using the equation. The first thing is you want to find there's 2 things that you need to find out. The first thing is you need to find out what is the first number and what's the common difference. Those are the 2 things you need to find out, okay? What we're going to do is we're going to use the formula, the equation for an arithmetic sequence, okay? So the equation for an arithmetic sequence is as follows. It's a sub n equals a sub 1, that means the number in the first position, plus, open parentheses, n minus 1, close parentheses, times d. Okay. So a sub 1 is going to be the first term, right? The number, here we're going to say first term. And then d, of course, is going to be your common difference. Okay. So we're going to go back and plug it in. So the first thing is we needed to find out the first term and the common difference. And I see in the chat that we found the common difference. You're right, it is a 1. And what about the first term? The first term is going to be the 4. Very good. So what we're going to do is we're going to go back and plug it in, okay? So we have a sub 1. Instead of that, we're going to substitute it with 4 plus, open parentheses, n, we're going to leave it alone, n, and then we're going to put minus 1, and then d is the number that we found that we're going to sub, which is 1. So the 2 numbers that we needed was the 4 and the 1, and that's what we plugged in. And so, yes, you are correct. The n stands for the position. But in this case, because of the formula, it's kind of like we're using it for x, okay? but they use the letter N whenever you talk about arithmetic sequences. Okay, so what we're going to do here is we are going to distribute the 1 into each part. So we end up with 4 plus, okay, 1 times n is n, and then 1 times -1 is -1. So we distribute first, and then we're going to add our like terms, right? We're going to combine our like terms. So we have 4 minus 1. So we have n plus 3. Okay, so that's our equation. So the a sub n equals n plus 3. This is the equation. Okay, now to find the number in the 25th position, what we're going to do is we're going to use this equation and we're going to plug in the 25, okay? And that's where the letter N comes into place. So we're going to say, okay, we want to find a sub 25. So where N is, we're going to plug in a 25. So it's going to be 25 plus 3. So what number is in the 25th position? The number is 28. So that's the second answer, okay? Okay, here's number 5. So the pattern is 8, 16, 24, 32. And it's the same directions. We want to find the equation and what number goes in the 25th position, okay? All right, so the formula, the equation was a sub n equals a sub 1 plus, open parentheses, n minus 1 times d. Okay, so we said the a sub 1 is going to be what? And d, this is the common difference, right? So what number do I plug in for a sub 1? Yep. And then what's the common difference? 8. That's it. So let's go ahead and plug those in. So we have 8 plus n minus 1 times 8. Okay, we're going to distribute the 8. So we have 8 plus 8n minus 8. We're going to combine our like terms. We have 8 minus 8, which gives us 0. So our equation is, that's it, 8n. That's the equation. Now we have to find out what's the number in the 25th position, right? So we're looking for a sub 25 equals 8 times 25. Okay, use your calculator, plug it in, and what is the solution? What number is in the 25th position? That's it. You got it. 200 is correct. If you have to look at a graph and it says, does the graph represent an arithmetic sequence? Now, just looking at the graph, you can tell if it's an arithmetic sequence or not. The way you can tell is that the points lie on a line. If they make a straight line, then yes, it is an arithmetic sequence. Okay, to prove that it's an arithmetic sequence, what you want to do is look at the points, okay? And you can make a table based on those points. So for example, you have X and Y, and the first point we have 1 and 15, 2 and 12, 3 and 9 and 4 and 6. Okay, so here to identify if it's an arithmetic sequence, you can look at the points, you can draw them on the table, and your sequence would be the numbers in the output. So for example, you have 15, 12, 9, 6, and that's your sequence there, okay? Now, to check if it's an arithmetic sequence, you want to see the numbers. How did you get from 15 to 12? Well, we had to subtract 3, correct? Or you could say we added a -3. How do you get from 12 to 9? Is it the same common difference? Yes. And then from 9 to 6, is it the same common difference? Yes. So the question is it an arithmetic sequence? The answer is yes, because they have the same common difference, okay? So that's how you can check if it is an arithmetic sequence or not. Sometimes they will just give you the points and you need to know, okay, the sequence is the output. The 1, 2, 3, 4 represents the position, okay? Okay,